Hello, math students. Mr. B here. All right, we're going to be solving an applied problem that has to do with quadratic equations. This one's going to involve a right triangle. So here's the story. A right triangle has one leg that is 2 inches longer than the other. The hypotenuse is 6 inches. How long are the legs? All right, so let's start with a picture here. And a right triangle has a square corner in one of the corners. And what is this problem telling us? The legs are the sides of the triangle next to the right angle. And it says one of them is 2 inches longer, and this bottom edge looks like it's the longer one. So if we called the shorter one maybe x, the longer one would have to be x plus 2 because it's 2 longer. The side opposite the right angle is the hypotenuse, which we've been told is 6 inches. I'm just going to write 6 there. Now I think everybody remembers the Pythagorean theorem. I'm going to have trouble spelling it maybe. Pythagorean theorem. And I think usually you're used to seeing it with an A and a B and a C, and the story goes A squared plus B squared equals C squared. So that's the bit of theory that we're going to need here to solve this problem. So the A and B are being played by x and x plus 2. So we're going to have x squared plus the quantity, so in parentheses here, the x plus 2, that gets squared, and that's going to equal 6 squared. All right, so this isn't looking very quadratic quite yet. I mean, I can see the x squared, but there's this funny binomial thing that's getting squared. Let's multiply this out and clean it up and see what we have. So we have x squared, and I've done these a lot so I don't have to FOIL this. I know that in my head I can just write x squared plus 4x plus 4, and the square of 36 is, the square of 6 is 36. There we go. All right. Now let's clean this up. We have 2x squareds, so I can write 2x squared plus 4x. I need to get everything on one side. What if we take away 36 from both sides? That'll give us minus 32 on the left now and nothing on the right side. All right. I see that there's a common factor of 2 in all the terms. So what if we divide everything by 2? That's like dividing both sides by 2. Then we have a nicer looking quadratic. It looks like x squared plus 2x, right? Because 2 goes into 4 twice. 2 goes into 32 16 times. So we'll have x squared plus 2x minus 16 equals 0. Now if you think about this, this is not factorable over the integers. There's no two numbers that add to 2 and multiply to be negative 16. What's our next bet? We could complete the square. That's going to be hard. How about using the quadratic formula, right? So I see A is 1, B is 2, and C is negative 16. Quadratic formula says x is going to equal negative b plus or minus square root of b squared minus 4ac all over 2a. So here we have negative 2, right, because b is 2, plus or minus the square root. What's b squared? b is 2, b squared would be 4, right? And then we have minus 4, a is 1, and c is this negative 16. And underneath we have 2 times a, but a is 1. Now let's start to see what we've got here. Negative 2 plus or minus. Now what's under this radical here? I see a 4 minus, well, it's a minus, and we're going to get a negative here because there's a negative 16, so it's really plus. 4 times 16, well, 2 times 16 is 32, and double that, you get 64. So 4 plus 64 is 68, right? So we're going to get plus or minus the square root of 68 over 2. Now, I'm a little worried about that radical. Maybe it should probably be simplified. So let's see what would happen if we tried to simplify it. Let's get the prime factorization for 68. 2 goes in 32, 2 goes into that 6, whoops, sorry, it doesn't go in 32, it goes in 34, right? Sorry. Almost made a mistake there. That would have been tragic. All right, half of 68 is 34, then 2 goes into that 17 times. So really, square root of 68 is square root of 2 times 2 times 17, and I see a pair of 2's there, so this is really 2 square root of 17. Okay, we're almost there. Negative 2 plus or minus 2 square root of 17 divided by 2, and I see a common factor here, right? It's the easy way to see it is to break it up and just say this is negative 2 over 2 plus or minus 2 square root of 17 over 2, and you can see the 2's cancel where we have negative 1 plus or minus square root of 17. Now that's what x is. That was one of the legs. So this guy is negative 1 plus square root of 17. You're wondering, well, why'd you throw away the minus in that figure up top? It's because it's a length, right? And lengths have to be positive. So we're going to toss out the negative. X is negative 1 plus the square root of 17. And what's the length of the other leg? Well, that's 2 longer. So we'll take the x, negative 1 plus square root of 17, and add 2 to it. And here we see that we have negative 1 plus 2. That gives us 1 plus square root of 17. So what's the deal? One leg is negative 1 plus 17 inches, and the other leg is positive 1 plus the square root of 17 inches. So there's a right triangle problem that involves a quadratic equation. Hope you enjoyed that. We'll see you next time.